Hi, today we'll be talking about quantum numbers while I play Nightmare Mode. I hope this will be a short video, so let's start. What are quantum numbers? Quantum numbers are sets of values that describe an electron of an atom. There are four types of quantum numbers, namely principal quantum number, which is denoted by n, angular momentum quantum number, which is denoted by L, magnetic quantum number, which is denoted by M sub L, and spin quantum number, which is denoted by M sub S. Okay, so let's start with principal. Principal's main meaning is it's the main energy level of, or the shell of, where an electron is located. Possible values could be theoretically up to infinite, but for the sake of this class, we'll only use 4 since that's what the most teachers teach anyway. Next is angular momentum quantum number, M, which is L. The the only thing you need to remember about angular momentum quantum number is that it's always one value lower than the principal quantum number. So to find the angular momentum, the formula you need to think about is n minus 1. That's it. So let's say my principal quantum number is 3, and you just subtract 1 from 3, which is 2, meaning that your angular momentum quantum number will be 2. Magnetic quantum number is also an easy concept to understand, since it contains the values of everything from the negative angular momentum, since it says m sub l. For for the example earlier, we got 2 as an answer for our angular momentum, meaning we just make every integer has that has wait, let me fix my sentence. That's You just make the angular momentum negative and find all the integers around that range. For example, this is the magnetic quantum numbers from our angular momentum, which is -2, -1, 0, 1, and 2. Basically, you only need to find the range of the negative negative angular momentum to positive angular momentum, which is what I did here. So we got -2, -1, 0, 1, 2. And for spin quantum number, it's easy to remember. When the arrow is up, you get a positive 1/2. And when the arrow is down, you get negative 1/2. For Let's make another example. Let's say our principal quantum number is 4, n equals 4, and what's 4 minus 1, just to get the angular momentum quantum number. 4 minus 1 is L equals 3. That's our angular momentum quantum number. And to find the magnetic quantum number, you just find the range of the negative angular momentum to the positive angular momentum quantum number, which is m sub L equals -3, -2, -1, 0, 1, 2, and 3. And finally, for spin quantum number, me just find whatever's the last arrow on the spin. Like I said earlier, if it's arrow up, it's positive 1/2. For this example, let's just use our positive 1/2. Oh, you get the point. Whatever I wrote there is, that's exactly it. Now it's clear horribly. If you have more questions, I'll just write it down in the description so it's easier to understand. If the gameplay is distracting, so you can just read it here. I'll make a part 2 about kinematics next. So stay tuned for that, I guess. You know what? I think I should have cleared it while explaining. That's my bad. think that's it for the video. I'll do my best next time to try to explain because I know I explained this so horribly. So, I see ya. See ya in the next one.